Welcome to differential geometry, that is SMA B431. It's a year 4 mathematics unit for the students taking mathematics in higher education. We shall be tackling vector algebra, and we have a question. Consider triangle OAB. Let vector A to represent OA, vector B to represent OB, and vector OA is 3 units, vector OB is 4 units, angle AOB is given as 45 degrees, and we are told to obtain A to B, A onto B, that is the first question. So if you want to solve A onto B, we have to say, coming up with the magnitude of A, and then multiplied by that of B, cos theta. Remember, theta is 45 degrees. So A, we have said, is 3. Told that OA is 3 units, so our A is 3. Multiplied by B, our B is 4. Then we multiply this by cos 45. So this gives us 3 times 4, it's 12. And then cos 45 is the same as 1 over root 2. Remember, this is from the special angles. I'll show that. So this simplifies to 6 root 2. So let me show the concept that gives cos 45 as 1 over root 2. We usually consider a right angle triangle where this angle is 45. Here we have 1, 1. So that angle is also 45. Coming up with this is the same as 1 squared plus 1 squared, the square root. That is 1 plus 1. So we have the hypotenuse as root 2. So cos theta equals to adjacent all over the hypotenuse. Now the adjacent of this angle, that is 45, its adjacent is 1, and its hypotenuse is root 2. So that is where we come up with the cos theta, that is cos 45, equals to a half. Let us meet in our next video where we shall be tackling the second part of this particular question, that is Roman 2, which reads determining the scalar projection, of B onto A. That is our next question. Determining the scalar projection of B onto A, it's also very simple. This is how we write B onto A, vector B onto A, which is usually expressed as vector A multiplied by vector B all over the magnitude of vector A. So we had already calculated vector A onto B in part 1, and we have it as 6 root 2, and then the magnitude of A, or rather the length of A, we were already given in the question as 3. So this simplifies into by 3 1 by 3 2, and therefore the scalar projection of B, vector B onto vector A, becomes 2 root 2. So stay tuned, subscribe, like, and share for more SMA solutions.